All right, so we're going to talk about some momentum here, and I have three topics that I want to talk about. I want to talk about what an open system is, how to identify an open system, and then we will work an open system problem. All right. Then we'll take a look at a closed system, and then just do a quick problem there, and then probably look at some F versus T graphs very quickly. All right. So first of all, let's talk about an open system. An open system, when we're referring to momentum, is anything where there is an external force or an outside force. So a closed system, there's no external forces. That means that there's only partner forces happening there. But in the open system, there is external forces. So usually, I say this is a rule of thumb, but usually we define the system as like a single object, so like a tennis ball bouncing off a wall. If we're just looking at the tennis ball, that would be an open system. That's one clue. Another is like I said, if there's an external force. So if there is a multiple objects in the problem or something like that, and you're having a hard time narrowing it down to a single object, is there another force other than the action-reaction forces? So for instance, when the ball hits a wall, that would be ball on wall. That would be one force. The other force would be wall on ball. So those are the two partner forces. If those are the only two forces, then it's a closed system. But if there's something holding that wall in place, that's an external or outside force, and so it's an open system. Classic problem with this is like if you throw a tennis ball against the wall. So let's say here's our wall, here's our ball, all right, and our ball is traveling at the wall, and I'm going to keep the numbers really nice here. Let's say it's like 5 meters per second, and when it hits the wall, so down here, it bounces off the wall this way, and we're going to say it comes off the wall at, let's say 3 meters per second. And we're going to say the mass of the ball is 1 kilogram. All right, and let's say I want to calculate something like what's the impulse that the ball or the wall imparts on the ball. All right, so well here you need to use, this is an open system. The ball is our only object here that's changing velocity. So it's our only system. If you're confused and you say, well, there's a wall there too, the wall again has an external force acting on it, so it's open. Again, really in an open system, we can only apply this to a single object. So what we're going to get here is the impulse is equal to the change in momentum, or this would be P final minus P initial. Now, one thing you got to keep in mind here is that when it is moving to the right, this speed or velocity is positive, and this velocity is negative. Missing a negative sign is so often the case here. There are people miss this. Once you have this, it's really a piece of cake. It just becomes mv final minus mv initial, and you've got it. So I'm going to factor out the m. So it's 1 times, and the final velocity is a -3 minus the initial velocity, which is 5. And so we get a -8, and then our units would be Newton seconds. So that would be the impulse there. All right. Again, the way we identify this is there's only a single object changing momentum, or there's an external force. And what keep in mind, what happens here is that momentum is not conserved. So it does not stay the same before and after. It changes, as we see here in this problem, and that change in momentum is equal to the impulse. Okay. All right. So moving on to the closed system. So there's the open system. Let's talk about the closed system. Now, the closed system is the opposite of the open system. So just all the things I just told you, we would just do the opposite. So in a closed system, two objects are going to be changing their momentum. And then the forces there are just the partner forces, so action-reaction partner forces. So object A hitting B and object B hitting A. That's the only force that we have to worry about. And then as a result of that, what we end up with is, well, because those are partner forces, we know that the forces are equal to each other, except one's negative because it's in the opposite direction. If we come in and we multiply both sides by t, because the time for the impact will be the same, what you end up with is you get the impulse of one is equal to the negative impulse of the other. That's the same as the change in momentum for one is equal to the negative change in momentum, of the other. What ends up happening is that the initial momentum of object A plus the initial momentum of object B is equal to the final momentum of object A plus the final momentum of object B. Or, as we start with, the initial momentum is equal to the final momentum. So this can be asked, there's going to be a lot of questions asked about this, because there's all sorts of applications where I can say, hey, give you enough information like about the final state of the system, and then ask, okay, what's happening at the beginning of this interaction or something like that. And so that will happen repeatedly, where, like for instance, a recoil situation. The initial momentum of the system is 0. And after the event, after the explosion or the recoil event, the momentum is still 0. You just have objects traveling in opposite directions. So the individual momentum of A or the individual object B will not be 0, but you add them together and it does equal 0. Okay, so keep that in mind, that can happen as well. Now, recall that in a closed system, there are 3 interactions where this is true. The first is a recoil. This is where the two objects, start together, something happens, and they explode apart. So somebody throws something, there's shoot a gun, a cannon is fired, or some sort of explosion. Those are all recoil events. Next, there is an inelastic, and this is where they start apart, collide, and end up sticking together. And then the last one is an elastic collision, and this is where they start apart, collide, and end up apart. Okay, so those are the 3 things there. In each of those 3 scenarios, this equation down here, this PI equals PF, is true. And when we get that, we can do this. Now, in some of these cases, in many of these cases, is entirely possible for one object not to be moving at one point or another. And so you might get something where, the momentum of object A or object B is 0 until it's struck by the other object and creates a change in momentum. And then, that gets, it's moving after the collision or vice versa. All right. All right. Now, moving right along to F versus T graphs. Let me go ahead and hit clear. This will probably clear out everything. Yep, there it goes. So when we do F versus T graphs, we'll just graph these here. And these are usually graphed with really nice whole numbers. So like this would be 1, and this would be 2, and this would be positive in newtons, and this would be -1 and -2. And then you got 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. I'm going to extend this a little longer. 1, 2, 5, 6, 7, 8, 9. Now, usually what happens, we have some sort of, hold on, let's undo that. Try that again. Here we go. Go up to 2 for there. We'll go down to 2 for 1. And then, yeah, we'll go up to 1 for 1. Okay. So say we get 3 impulses here. And we'll just call them A, B, and C. To find the impulse at each one, we just find this area inside this little rectangle it makes. So here it's, this is 1, 2, 3. This is 2 seconds from here to here and 2 newtons high. So this is 4 newton seconds. Down here, we got 2 down for 1 second. This would be a negative 2 newton seconds. And here's 1 for 1 second. So this would be 1 newton second. These would be positive. This one's negative because it has a negative force. So there will be a negative change in momentum, which usually means it's slowing down. Now, it is important to note that this does not mean that the momentum is less than 0 or it's negative. That does not mean that. It means there's a change that's negative. If you start here with an initial momentum of 0, we'll say newton seconds, the momentum at second 4, so P4, would be a positive 4 newton seconds. After impulse B, so right there, all right, we'll call that at second 4, 5, 6, 6.5. So we'll say the momentum at 6.5. After a change of 2 would still be a positive 2 newton seconds. So you can have a negative impulse, but you not necessarily have a negative momentum. It's possible to keep them apart. So there's a difference between having a negative impulse or a negative change in momentum and having negative momentum. All right? Negative impulse means you're just pushed in the negative direction. Negative momentum means you are moving in the negative direction, and there is a difference. All right, that'll wrap up this tutorial, and if you have any questions, just email Champ directly.